Section 4.5, Solving Radical Equations. So we have the square root of x equals 8. So in order to solve this, in order to get rid of that square root, we're going to square both sides. So we have the square root of x squared equals 8 squared. Whatever you have to do to one side, you have to do to the other. Now, assuming that x is positive, the square root of x squared is going to be x, which equals 8 squared, which is 64. And we can check it. The square root of 64 is 8. So all of these that we're going to be doing, we're going to be assuming that that is over real numbers. We can't take the square root of a negative number. Okay. So, and again, if you want to take the time to check, go ahead and write it out. The square root of 64 equal 8. That's a question. 8 equals 8. So it checks. When we have a problem like this where here's our square root, well, we have to isolate that square root first. So we're going to subtract 5 from both sides. So we're left with 2 square roots of x equals 8. Divide by 2. The square root of x equals 4. Now we're going to square both sides. The square root of x squared is x equals 4 squared is 16. And then whether you're checking it on paper or just plugging in to check it, the square root of 16 is 4. 4 times 2 is 8. 8 plus 5 is 13. But you have to be careful because this step right here, if you're squaring, if I just take some numbers, if I say negative 3 equals 3, this is not a true statement. But negative 3 squared equals 3 squared, this is, because you get 9 equals 9. So in some cases, you may actually have a negative on one side, a positive on the other, and when you square both sides, which is what we're doing here, you could force them to be equal, but the originals are not. So be careful because those are not equal. That's why it's more important than ever to make sure you check your answers as you go through. The square root of x minus 5 equals 3. Since it's isolated, that square root's isolated, we're going to square both sides. And we get x minus 5 equals 9. Now I couldn't move this 5 because it was under the square root. So this square root belonged to everything. So that's why I squared first. Now I can add the 5 plus 5 and we get x equals 14. And again, you could take the time to check it. 14 minus 5 is 9. The square root of 9 is 3. So always check with the original. Here, notice we have 2 square roots. This one's a little harder. Now, if we square both sides right now, we would have to FOIL this out, and we're going to have another square root in there. So before, I want to isolate one of them. So I'm going to add the square root of x to both sides. So we get 2 square roots of x minus 3 equals the square root of x. Now I'm going to square both sides. And notice how this one was isolated. The square root of x squared is x. 2 squared is 4 times the square root of x minus 3 squared is x minus 3. So when one of these square roots is isolated, if they're on each side, when you square, you will remove that square root. So now I have to solve the remaining equation. 4x minus 12 equals x minus 4x from both sides. And negative 12 equals negative 3x. Divide by negative 3. And we get x equals 4. If we check it, 4 minus 3 is 1. The square root of 1 is 2. 2 minus the square root of 4 is 2, so from here we get 2 minus here we get 2. 2 minus 2 is 0. But again, if you want to check on paper, you can check on paper as well. Same thing with this one. If I get an x equals the square root of x minus 1 plus 3, again I want to isolate that radical, that square root. So I'm going to subtract 3 from both sides. So we get x minus 3 equals the square root of x minus 1. Now I can go ahead and square both sides. Here we're going to get x minus 1, but x minus 3 squared is not x squared minus 9 or x squared plus 9. You have to rewrite this. That squared is that number times itself. So I'm going to rewrite it and FOIL. Here's x squared minus 3x minus 3x plus 9 equals x minus 1. So combine like terms, x squared minus 6x plus 9 equals x minus 1. Now because it's an x squared, I'm going to have to set it equal to 0. So I'm going to subtract x and I'm going to add 1. Subtract x, add 1 to both sides, and we get x squared minus 7x plus 10 equals 0. Now we have our quadratic equation. We could solve this by factoring if it factors. Quadratic formula. This does factor. X minus 2 and x minus 5 equals 0. So now if I set each one equal to 0, x minus 2 equals 0, x minus 5 equals 0, we get x equals 2 and x equals 5. And if we check these in the original now, 2 minus 1, so the square root of 2 minus 1, so 2 minus 1 is 1, the square root of 1 is 1, 1 plus 3, does that equal 2? And the answer is no. So we're going to throw that one out. That one does not check. Okay. If I check 5, 5 minus 1, so here's 5 equals, 5 minus 1 is 4, square root of 4 is 2, 2 plus 3 is 5. So 5 equals 5. Okay. And if we write it out, so here again, if we say 2 equals the square root, 2 minus 1 plus 3, does 2 equal the square root of 1 plus 3? Does 2 equal 1 plus 3, 2 equal 4? And the answer is no. So that's why we threw that one out. Does 5 equal the square root of 5 minus 1 plus 3? 5 equal the square root of 4 plus 3? Does 5 equal 2 plus 3? Or 5 equals 5? Yes. So that's our only answer. In some of these you may have no solution. Some you may have one solution, some you may have two solutions. But you really need to check to see what are the solutions and what are not. Here again, here's a radical, the square root of 2x plus 5. I want to isolate that, so I'm going to minus 1. So we get the square root of 2x plus 5 equals 2x minus 1. Now I'm going to square both sides. So this is 2x plus 5 equals 2x minus 1 times 2x minus 1. Again, I'm going to have to FOIL that out. So it's 2x plus 5 equals 4x squared minus 2x minus 2x plus 1. Negative 1 times negative 1 is plus 1. So we get 2x plus 5 equals 4x squared minus 4x plus 1. So we're going to subtract 2x from both sides. We're going to subtract 5 from both sides. And I'm just going to reorder this. So here's my 4x squared. Minus 4x minus 2x is minus 6x. Positive 1 minus 5 is minus 4 equals, and on this side we get 0. So I notice all of these are even, so I'm going to divide everything by 2. Whatever you do to one side, you have to do the other. So now we get 2x squared minus 3x minus 2 equals 0. And getting those numbers down is just going to help me when it's quadratic formula or factoring. This one does factor as well. It's 2x x. Now the factors of 2, I can't put a 2 here, so I'm going to go 1 and 2, because that would tell me that if I put a 2 here, then I would have a common factor of 2 up here, which I don't. Now I need 1 is minus, 1 is plus. So as I multiply these, we're going to be a minus here and a plus here. And if you check this, this would be, here's our 2x squared, here's our minus 4x plus 1x is minus 3x minus 2. So 2x plus 1 equals 0, x minus 2 equals 0. This we're going to get x equals negative 1/2 and x equals positive 2. Again, if we check it, if we put a negative in here, negative 1/2, we're going to get it 2 times negative 1/2 is a negative 1. This is positive, equal to a negative, not check. But you could always plug it in again if you want. 2 times negative 1/2 is negative 1. 2 times negative 1/2, negative 1 plus 5 is 4. Square root of 4 is 2. Is 1 plus 2 equal to negative 1? And the answer is no. If we check 2, 2 times 2 is 4. 2 times 2 is 4 plus 5 is 9. The square root of 9 is 3 plus 1 is 4. So we get 4 on one side, we get 4 on the other. So that is our answer, x equals 2. So now if I start this next problem, the square root of x minus 5 minus the square root of x equals a negative 1. So again, I want to isolate one of these square roots, so I'm going to add the square root of x to both sides. We get the square root of x minus 5 equals the square root of x minus 1. Now that I have it isolated, I can square both sides. The square root of x minus 5 squared is x minus 5. But because I have two terms here, I'm going to have to rewrite this one times itself, because I'm going to have to FOIL. So we get x minus 5 equals the square root of x times the square root of x is x minus the square root of x minus the square root of x, and negative 1 times negative 1 is plus 1. So we get x minus 5 equals x minus 2 square root of x plus 1. Notice we still have a square root there, so again I want to isolate that, so I'm going to minus x from both sides. I'm going to subtract 1 from both sides, and we get negative 6 equals negative 2 square roots of x. So we're going to divide by negative 2, divide by negative 2, 3 equals the square root of x. So now that this is isolated, again I'm going to square both sides, and we get 9 equals x. Now again, you should take the time to check it. 9, if I was to check this, the square root of 9 minus 5 minus the square root of 9, does that equal negative 1? So does the square root of 4 minus the square root of 9 equal negative 1? Does 2 minus 3 equal negative 1? Negative 1 equals negative 1. So it checks. But you really should take the time to check these so you don't miss one of those where it doesn't check and you have to throw it out. The square root of x plus 4 plus 8 equals 5. going to subtract 8 from both sides. Square root of x plus 4 equals negative 3. So I'm going to square both sides now, and we get the x plus 4 equals 9 minus 4, and we get x equals 5. But if we were to check that, does the square root of 5 plus 4 plus 8 equal 5? Does the square root of 9 plus 8 equal 5? Does 3 plus 8 equal 5, or 11 equal 5? And the answer is no. So this does not check. And since that's your only possible solution, and we have to throw it out because it doesn't check, we're going to say there is no solution. And again, we could have caught it right here. Here's a square root of x plus 4, which is positive, equal to a negative 3. Can a positive equal a negative? And the answer is no. A square root or an even root cannot equal a negative. But if you square both sides, notice how that's a positive now, and we can get a solution, x equals 5. But if you don't check it, you're going to have a problem, because you can see that this particular doesn't check and there's no solution for that. So be careful. Take the time to check your answers. Find the x-intercept of this graph. The x-intercept is when the function equals 0. So this is really saying the square root of 3 x minus 4 minus the square root of x plus 2 equals 0. So add the square root of x plus 2 to both sides, and we get the square root of 3x minus 4 equals the square root of x plus 2. Now, since it's isolated, we can square both sides. We get 3x minus 4 equals x plus 2. Now, again, the reason we don't have to FOIL this is because this is one square root squared. So that's going to take care of that. The square root of 3x minus 4 squared. So if we solve minus x, and we get 2x minus 4 equals 2, add 4 plus 4, and 2x equals 6, divide by 2, x equals 3. So when y equals 0, or when that functional value equals 0, x equals 3. So the x-intercept is 3, 0. And again, if you want to check it real quick, 3 times 3, 9 minus 4 is the square root of 5. 3 plus 2 is the square root of 5. Here we get the square root of 5 minus the square root of 5, which is going to be 0. So solve r equals the square root of gmk over f. We want to solve this for f. Well, since it's already isolated, this radical, this square, we're going to square both sides. So we get r squared equals gmk over f. Now we want to solve for f. Since that f is in the denominator, we're going to multiply both sides by f. So that f will cancel there. So we get f r squared equals g times m times k. And if we want to solve for f, we need to get rid of this r squared now. So we're going to divide by r squared. Whatever you do to one side, do to the other. And we get f equals gmk over r squared. So now we're getting into not just square roots, but we could have a cube root, a fourth root, a fifth root, another cube root. So how we solve this is going to be very similar. We have to isolate that radical. So minus 7 minus 7. So we have the cube root of 2x minus 4 equals 2. Now how do we get rid of a cube root? We're going to cube both sides. So this is going to be a 2x minus 4 equals 2 cubed, which is 8. Now solve for x. Plus 4. So we're adding 4 to both sides. 2x equals 12. Divide by 2. And we get x equals 6. And again, so here's our solution. But if we check it, 2 times 6 is 12. Minus 4 is 8. The cube root of 8 is 2. Plus 7 is 9. Same over here, minus 5 from both sides. Now we get the fourth root of 3x minus 1 equals 3. Now to get rid of that fourth root, we're going to raise to the fourth power. And we get 3x minus 1 equals 3 to the fourth is 81. Add 1. 3x equals 82. Divide by 3. X equals 82 thirds. And you should take the time to check it. The fifth root, so again that 2 is outside, we're going to add 2 to isolate that fifth root. 5x plus 14 equals 3. This time we're going to raise to the fifth. And we're going to get 5x plus 14 equals 3 to the fifth is 243. Subtract 14 from both sides. 5x equals 229. Divide by 5. X equals 229 divided by 5. It doesn't reduce, so you can leave it in fraction form. This would be a nice decimal because you're dividing by 5, so I would accept a decimal here as well. Here, now be careful on this next one. This is really 5 times a cube root. So we still have to isolate that cube root, so we're going to add 3 to both sides. So this is 5 times the cube root of 7x plus 2 equals 10. Divide both sides by 5. That 5's outside, so we get the cube root of 7x plus 2 equals 2. Now we can take the cube of both sides. 7x plus 2 equals 8 minus 2. 7x equals 6. Divide by 7, so we get x equals 6 sevenths. Now, when we're solving using the intersect of your calculator, I had to get my calculator. So what we're going to do is we're going to set y1 equal to one side, y2 equal to another. So if we look on here, so y1 equals the square root of x plus 6, and in y2, 6 minus the square root of x plus 4. Now I'm going to go zoom 6 just as a starting. So I want to see what this looks like. So here's a square root, and then that other square root's opening down. I do see my point of intersection, so this window will work. So the next thing we have to do is we have to go second trace to get in that calc mode. So it's second trace, and you'll see these options, different options here. 0 if you're looking for an x-intercept, minimum if you want a min, a max. We want the intersect. So we're going to go 5. Notice how it says first curve. It doesn't matter which one we select as our first curve. We're going to hit enter. Second curve, well, that's going to be the other one. We're going to hit enter. Now guess, if there's only one point of intersection, we're just going to hit enter again. But if you had 2 points of intersection, you would do exactly the same thing, but you would use your arrow keys to move around to get closer to that point of intersection, and then hit enter for your guess. And notice we have roughly 4.027777 repeating. So that would be our solution. If we're solving this equation for x, we want the x value. So it's going to be, so our solution here is going to be x is approximately 4.027 repeating. Or if it wanted you to round, it would be 4.028, depending on what it asks. Ask for rounding. This one, round any solution to the second decimal place. So our answer is going to be 4.03 would be the answer. So just make sure you read the question to see where it wants you to round to. I hope that helps for section 4.5.